All right, so that is the correlation. That's the book numbers and the online version, okay? So those are the correlated numbers that we're going to work on, okay? Enough said? Yes or no?
Yes.
Okay. All right, and we'll check them off as we do them. Clear? Okay? Yes? Okay, good. So let's begin with 57. Let's begin with 57. All right, now, yeah, 57, right? Now, I made some videos yesterday that I haven't put up yet. So, I made, let's see, I made 2 or 3 of them from yesterday. So, I pretty much, except, I don't think I did mole fractions yet, but I'll do mole fractions. But I've done every other type of calculation. All right, so let's begin with 57, shall we? No. Is that right? Yeah. It says define molarity, moles per liter, moles of solute per liter of solvent. That's the definition of molarity. It's a concentration where the numerator is moles of solute over volume of solvent. Okay? So we're going to have moles solute over liter solvent equals M. Okay, now, then it says to do A and B. And it says, calculate the molarity of each of these. It says 1 mole of potassium chloride in 750 milliliters of water. Okay? Let's expand this formula, okay? This is going to be grams over gram molecular weight, correct? That's what that's going to be. That's a mole, right? Correct? Right? Divided by milliliters over 1,000, correct? That's an expansion of that equation, yes? Okay, now, it says, the first one is relatively easy. Both are actually relatively easy. It says 1 mole over 750 milliliters. So it's going to say the molarity is going to equal, what did it say, 1.5? 1 mole. 1 mole over 750. I mean, if you can simply do the shifting, the decimal point, you'll see that this is going to be 1 over 0.75. I need calculators out. So what is 1 divided by 3/4? Come on, guys. 4/3, right? 1.3? Isn't that right? Yes? Okay. 1.3 M. And the next one says, it says 0.5 moles over 1.5 liters. 0.5 moles over 1.5 liters. So the next one says 0.5 moles over 1.5 liters. What's that going to equal? What's 0.5 divided by 1.5? 0 point what?
3.
Yeah, so it's going to be 0.33 molar. Clear? Easy? Is that on the... Is that up?
Yeah.
Is that on? Okay, good. Now, so that's number 57, okay? Yes? So let's do, so we'll call that molarity. And what's next? What number's next? 58, 59, so let's do 58. All right, this is a good one. This is good. This is a good one. All right, it says, how many milliliters, so we're going to get the milliliters thing, right? How many milliliters of 0.5 molar, so let's write that down right away. Okay, so 0.5 molar, okay? How many milliliters of 0.5 molar, let's get the particle down, that's also going to be important. KCl, because you're going to need that, right, for the, what? If you've got to do moles or anything like that, right? So you want to put the mole molecular weight down right away. What's the mole molecular weight for potassium chloride? What is it? What's the gram molecular weight? What is it? Come on, guys. You can do this. Don't stare at me like you're not participating. Right? 35 and 39 is what? 74? Okay. Right? Yes? Okay. Now, so it says how many milliliters of 0.5 molar potassium chloride solution would you need to dilute to make 100 milliliters of 0.1 molar potassium chloride? So what are we doing? What's this? What's the equation that we're using? Very good, Aiden. Excellent. It's going to be M1 V1 equals M2 V2. This is molar volume. The volume of that molarity equals the product of the two, equals the volume of that molarity, the product of the two. So what's going to be M1 V1 M2 V2? Always important to make a list. Always important. So what's what? So what is 0.5 molar? What's the volume that corresponds to that? X. Okay. So what is M2 and V2? What is it? 0.1. And what is the volume? What is it? 100 milliliters? Yes or no? You with me? Okay, good. So, what do I set up? I say 0.5. Can I leave off the unit labels? Yes? Yeah, because I have everything done. Molarity, this is molarity, milliliters, milliliters. I'm going to calculate it in milliliters. Is that okay? Yeah, that's okay. All right, so I can leave off the unit label. So it's going to be 0.5. What am I going to put for V1? Don't do X, man. Don't do X. Get over it. You know, be friendly with letters. Put there what it is. What is it? V1. Don't put X. You'll be completely confused, right? Put it what it is. Equals 0.1. And then what's V2? 100. Right? Air's already there. So what's the answer? What's the answer?
20.
What is it?
20.
20 what? 20 milliliters. Okay? Alex, you all right back there? Everything's cool? Excellent. 20 milliliters. You get it? You with me? Simple or what? I mean, is it hard? Okay. All right, we'll do the first bunch and then we'll quit this video. We'll go on to another one, all right? Okay. So, what's next? 59. Calculate the molarity. So we're going to do molarity again. of a solution that contains 0.5 grams, mass equals 0.5 grams, sodium chloride, yes? In 100 milliliters of solution. Is that of solution? Of solution. Okay? Yes? So that's going to be 100 milliliters. Let me step back for a second. Let me step back, and I do this a lot, and I have to stop doing it because it's wrong. Is what it is. I know what to do. I simply sometimes state it incorrectly, and I'm sorry. I should know better. But molarity is going to be moles of solutes. Look up molarity in the book right now. Look up molarity in the book. What's the definition of molarity? Kennedy? Of what? Of solution. 1 liter. I sometimes say solvent, 1 liter of solvent. I just do that. It's wrong. Because this is not going to raise the volume at all, so I just always say solvent, but it's wrong. It's 1 liter of solution. Okay? It's 1 liter of solution. I looked at that and I'm thinking to myself, I did it again, I told them. So do you understand that? What molarity is? 1 liter of solution. You get that? You sure? You sure? It's not 1 liter of solvent. It's 1 liter of solution. Okay, good. So what's going to be this? What's going to be the answer to this? Let's expand this again. Let's expand this. The molarity equals equals grams over gram molecular weight over milliliters over 1,000. Right? So this is going to be 0.5 over what?
58.
Over what?
58.
58, good. Over what? Over 100 over 1,000. Or just 0.1, right? So what is 0.5 divided by 58?
0.008.
What's it going to be?
0.008.
0.008 moles. Is that correct? Is that what you said? Is that correct? Okay. Divided by 0.1. What's that? Equals what?
0.09.
Well, it's 0.008, he said. It's rounded to 0.009? Arminda? Do that again. 0.5 divided by 58.
Here. Right.
It's 0.0086.
Is that correct? So it's not 0.8, it's 0.008, is it? It's 0.009? Okay, that's important. Okay. And that'll be what? 0.09%. No, I'm sorry. Not 9%. 0.09 molar. Is that correct? Is that on there? Is it on there? Ray, my videographer's not here. Oh, that's easily on. Okay, good. Any questions on that? That's a good one. 60, do we have to do 60? All right, calculate the moles and grams of solute in each solution the moles and grams. All right. So let me put the four solutions on the board. Okay. It's going to be A. Is going to be 1 liter of 0.5 molar NaCl. B is going to be 500 milliliters of 2 molar. Start doing these, the gram molecular weights, please, while I'm doing this. All right, you understand? That's 58, I know, but what's potassium nitrate, right? So start doing that while I'm doing this. 250 milliliters, 0.1 molar calcium chloride, and D, 2 liters, 0.3 molar okay? So I want to know the moles and grams of each, okay? So we'll do moles and grams of each, okay? Okay, so let's do the mole, we'll do the gram molecular weights over here. This is 58 grams. What's potassium nitrate? 39, 14, and 48. What do we got? Come on, guys. You guys got to do this. T, are you working back there or not?
101.
What is it? 101? All right. What about calcium chloride? 40 plus 70, 110. What about 46 plus 32 plus 64? What do we got? Come on, guys. 46 plus 32 plus 64.
142.
What is it?
142.
142. All right, good. Now, so I have 1 liter of 0.5 molar. So what's the number of moles that go here? What's the number of moles that I have? Right? 0.5 molar, right? 0.5 moles. So I don't need to do this. So 0.5 moles, and then the mass would be what? No? Half a mole, man. That's 1 mole, right? 29, right? And 500 milliliters of 2 molar, right? Right? Same as 1 mole, right? Correct? So there's going to be 1 mole of this, and then 101 grams. You with me or not? Don't say you're with me if you're not with me. Fight it. Come on. Fight it. Fight it. Don't make the deadly mistake. Well, I'll wait till I get home and I'll figure this out. I don't feel like doing it right now. No. It's far, far more efficient to fight it now, and it may be painful. What about this one? 215 milliliters of a 0.1 molar solution. So this is 0.1 moles in 1,000, right? So it's 0.1 moles in 1,000. Is it going to be a quarter of that? What's a quarter of 0.1? What is it? 0.025. So 0.025 times 110. 0.025 times 110. To be about 2.5-ish, right? Ish. Maybe add a little bit. 3.0. What is it? What is it? 2.75. And 2 liters of 0.3. So isn't that going to be just 0.3 moles in 1 liter. So it'll be 0.6 moles, right? All right. So what's 0.6 times 142? It'd be more than half. It'd be like 71 plus some 85, okay? Get it? Are we done? What's the next the next problem I have to do? What is it? 61. Let's take a quick break. All right? And I'll come back and I'll start with 61, okay? Yes? All right?